So we will have the parameter, we will compare the DC series motor, PMDC motor, induction motor drive, BLDC drive and SRM drive. Here we are comparing electric motor drive and not only the motor. If we consider the starting torque, DC motor has the high starting torque, PMDC drive has the moderate starting torque, induction motor drive. Now remember, induction motor does not have the high starting torque, but when we say the induction motor drive, with the help of VFT we can achieve the higher starting torque. That's why I told you we are discussing induction motor drive, because it is better way. In current scenario we are not discussing only motor. So induction motor drive can definitely produce the high starting torque. Same the BLDC motors and SRM motor. This all can produce the high starting torque, but not the PMDC drive. If we consider the constant power region, as we discussed, we require the higher constant power region. It is moderate for the DC series motor drive, PMDC motor drive, as well as the induction motor drive has some limitation, but we can extend this constant power region in the BLDC drive and SRM drive much easily with compared to other motors. So here you can see the green large constant power region can be attained with the BLDC and SRM drive. The power weight ratio. So the power weight ratio of DC motor and PMDC motors are low because it requires the extra component like the commutator and brushes, which include the weight. And induction motor has the good power weight ratio. Good design can also change it from moderate to high, but BLDC and SRM motors are generally in the high power weight ratio. That means it comes with the compact and smaller size as a motor which compared to all other motors. So here is the benefit. If we consider the efficiency, there is in DC motors efficiency is less with compared to other, because there are certain losses in commutator and brushes also, and there are comparatively we can achieve the efficiency up to the 70-75 or beyond the 80% also, but here in this 3 motor we can achieve efficiency greater than 90%, and induction motor efficiency is high with the help of induction motor drive only. We need to use VFD or direct torque control, then only we can achieve the higher efficiency. Second point that we need to consider is the efficiency with the variation in load, because we say the variation in load, that means different condition at slow speed, high speed, with the one passenger, 2 passenger, 3 passenger, like the what is the load, accordingly the efficiency of the motor change, because motor is designed, induction motor is designed to produce the highest efficiency at certain amount of load. But with load variation, at the light load, efficiency of induction motor is reduced, but with the help of motor drive we can achieve the highest efficiency at different range of speed also. Otherwise when induction motor is running at the lower speed, its efficiency is degraded, but with the drive we can achieve. So we are comparing drive and it's written high. Likewise BLDC and SRM both has the highest efficiency even with the variation in load. Here we are having the benefit, with variation in load we are having the higher efficiency, because when vehicle is running at low speed, we also need to maintain the highest efficiency. If we compare effect of temperature variation and thermal consideration, that is here for the DC series motor it is least, but for the PMDC drive it is high, because when permanent magnet comes, magnet property deteriorate at the higher temperature and it affects the overall performance of the vehicle. The same thing happened for the brushless DC motor, which include the permanent magnet. Because brushless DC motor also include permanent magnet, it's also observe the effect of temperature variation, and higher temperature performance of BLDC slightly deteriorate. So we are having induction motor and SRM. These two motors can have the least variation on effect of temperature variation. If we talk about the controllability, the DC motors has the highest and easiest way to control the speed of the motor, But for the induction motor it is little bit complex algorithm, and to implement the speed control torque techniques it's required the direct torque control and VFD. But VFD has its own limitation because high dynamic response when we require, we need to use the direct torque control. On other side, BLDC and SRM can implement the voltage PWM and hysteresis current controller same way like we implement in the DC motor. So we can say the speed controllability is somehow easy in the BLDC and SRM to implement with compared to induction motor drive. The reliability of induction motor, BLDC and SRMs are highest, but because of the existence of brush and commutator, reliability of DC motors are somehow less. Let's come to the manufacturing cost. The manufacturing cost of DC motor and PMDC are high. First of all, it's required the magnet, so manufacturing cost is high because the cost of magnet is too high with compared to other component. And BLDC also use the magnet, so cost of BLDC is also slightly higher than the SRM and induction motor. And DC series motor cost is high because it's required the commutator and brush arrangement, and this required the additional process and material to cost. Here in BLDC, the magnet placement also, interior magnet placement, this increase the manufacturing process and it's also increase the manufacturing time, so overall cost will be increased. Where if we consider the SRM, it is having the simplest structure among the all motor, with having the rotor with no winding, only the laminated core, and stamping we need to join together to form the rotor, and stator also having the salient point in winding is also simple. So manufacturing the switch reluctance motor is the less in cost and also fast in process. So all this make it lowest cost when it comes to manufacturing cost of the motor. If we think about the maintenance, then maintenance of DC motor are high due to commutator and brushes, but induction motor is rugged and the maintenance cost is less, as we know. Same for the BLDC motor and SRM motor, the maintenance cost are less. So if we look at this table and green number, we can have ideally these three motor, induction motor, BLDC motor and SRM motor drives are preferred for the electrical vehicle application. Here SRM drive is more suitable for the electric vehicle application. However, brushless DC motors are used widely nowadays for the electric vehicle application, but the industry is going toward the switch reluctance motor because it does not use any magnet, and to avoid the limitation of magnet temperature variation, magnetic cost and supply of the magnet, we are now thinking about the magnetless motor which having the same kind of performance, so that the switch reluctance motors are gaining too much attention for the electric vehicle application nowadays.